Alright guys, in this video we'll be continuing to look at solving square root equations. The first equation we have is x is equal to the square root of 110 minus x. Now remember, the first step is to isolate your radical. Make sure there's nothing on the outside of your square root, which in this particular case, that's taken care of. So what I'm going to do is go ahead and move on to the second step, which is to square both sides. So I'm going to square this side and this side. So if I square x, I get an x squared. And if I square the square root of 110 minus x, your square root and your square cancel each other out, leaving you with 110 minus x. Now you should notice here that the equation we're working with is a quadratic. And when you're working with a quadratic, you have three options. You have your quadratic formula, you got your factoring method, and you also got your graphing method. So whichever method you feel comfortable with, you can go ahead and solve this quadratic. Now I'm going to go ahead and use the factoring method, but if you've got a calculator and you want to graph this and find your x-intercepts, you can always do that as well. Now first thing I'm going to have to do, since I'm using the factoring method, of course if you're using the graphing method you'd want to do the same, is to get this thing equal to 0. So I'm going to start by moving the x on the right hand side to the left hand side. So when I move it to the left, that minus x now becomes positive x. I'm also going to move 110. When I move it from the right to the left, we're subtracting it, so that now becomes a minus 110. And now the equation is equal to 0. Alright, so now what I need to do is I need to factor this quadratic. Now this one shouldn't be too difficult because we have a leading coefficient of 1. So we know in order to get the x squared, an x times another x would give us that x squared. What I'm looking for is for some factors of negative 110 that are also going to add up to our 1, our middle number here. Alright, so the numbers I'm going to use are negative 10 and positive 11. And that's because a negative 10 times 11 is a negative 110. And when you add those two together, you also get a positive 1. Alright, so now what I'm going to do is I'm going to take those two factors, the x minus 10, set it equal to 0. I'll take the x plus 11, set it equal to 0. And I'm going to find my two solutions. So this first one over here, I'm going to add 10, and of course 0 plus 10 is 10. So there's one solution. I'm going to come over here, subtract 11. 0 minus 11 is negative 11. So the solutions I found to this quadratic are 10 and negative 11. Now remember guys, you can find these two solutions also using the quadratic formula or the graphing method. Now we're not quite done yet because we still have to check our solutions, make sure they actually work. We could end up with one of those extraneous solutions. So what I'm going to do is I'm going to start by checking the 10. I'm going to take that 10, plug it back into that original equation, and we're going to see if we get a true statement here. So if I subtract 110 minus 10, I get 100. And if I take the square root of 100, I get a 10. And since 10 is equal to 10, we know that this is definitely a solution. Alright, so let's check that negative 11. We're going to do the same thing. We're going to plug it in. Alright, so let's see here. We've got a 110 minus a negative 11, which gives us a positive 121. And if I take the square root of 121, I get 11. And since negative 11 is not equal to 11, negative 11 is one of those extraneous solutions. So the only solution to this equation is 10. Alright, let's try another example here. Here we have the equation, the square root of negative 42 plus 13b is equal to v. Again, the first step is to make sure there's nothing outside your radical, which again, that's taken care of. We're going to go ahead and square both sides. And the reason we're squaring both sides is so that we can get rid of that square root or your radical. The square root and the square cancel each other out, leaving you with a negative 42 plus 13v equals a v squared. So once again, I have a quadratic here. So I've got to decide what method I'm going to use to solve this quadratic. For me, I'm going to go ahead and use the factoring method, but if you want to use quadratic formula or graphing, that's alright. I'm going to go ahead and get this thing equal to 0 first. So what I'm going to do is go ahead and move that negative 42 and that 13v to the right hand side. So I'm going to start with a 13v. I'm going to subtract it. So now I've got a negative 13v. Now I'm going to go ahead and move that 42 to the right hand side by adding it. So now I have a positive 42. So I now have the equation 0 is equal to v squared minus 13v plus 42. So now what I need to do is I need to solve this quadratic here. So as I did earlier, I'm going to go ahead and use the factoring method. I know in order to get my v squared, I need to multiply v times another v. Now what I need are some factors of 42 that are also going to add up to a negative 13. What can I multiply together to get positive 42? But when I add those two numbers, I get a negative 13. I'm going to use a negative 6 and a negative 7. And that's because negative 6 times negative 7 is positive 42. And a negative 6 plus a negative 7 adds up to a negative 13. Alright, so now that I have this factored, I'm going to take each one of those factors. We're going to set those equal to 0. And we're going to solve this. So we come over here and add 6. So 0 plus 6 is 6. Alright, so that's one possible solution. I'm going to solve this equation over here by adding 7. 0 plus 7 is 7. So these are the two solutions I have. However, we do have to check them, make sure that they actually work when we plug them back in. So what I'm going to do is I'm going to start by checking that 6. We're going to plug that in. So I'm plugging that 6 in for both of the v's. So the first thing I'm going to do is find out what negative 42 plus 13 times 6 is, which in this case is 36. And if I take the square root of 36, that's a 6. And since 6 is equal to 6, we got a true statement. So 6 is definitely a solution. But I also have to check the 7. So we're going to do the same thing again. We're going to go ahead and plug in that 7 and see if we get a true state. Alright, so let's see here. Negative 42 plus 13 times 7 gives us a 49. And the square root of 49 is 7. And since 7 is equal to 7, we got another true statement, which means that 7 is also a solution. So this equation has two solutions. They are 6 and 7. Alright, let's go ahead and take a look at one last example here. First step is to make sure there's nothing outside the radical, which again, there's nothing outside this radical. So we're going to go ahead and go on to the second step, which is to square both sides. So if I square the n, I get an n squared. And if I square the square root of negative 1 minus 2n, I get a negative 1 minus 2n. So just like the other two examples, we have a quadratic here. And in order to solve this quadratic, I'm going to go ahead and get this thing equal to 0 first. So I'm going to start by moving my minus 2n to the other side. And then I'll move my minus 1 over to the other side as well. So I now have the equation n squared plus 2n plus 1 equals 0. So again, you got to decide which method you're going to use to solve this quadratic. I'm going to continue using my factoring method. If you want to use the formula or graphing, that's alright. To get the n squared, we need to multiply n times n. What I need are some factors of 1 that are also going to add up to a positive 2. Should be fairly obvious. We're going to use 1 and 1. 1 times 1 is 1, and 1 plus 1 is 2. So just like I did earlier, we're going to take each one of those factors. We're going to set them equal to 0. And we're going to solve both these equations. So if I subtract 1, 0 minus 1 is negative 1. And if I do the same thing over here, you'll notice we end up with that same negative 1. Now for those of you using the graphing method, keep in mind, when you go and look at your graph, you're only going to see one x-intercept. Okay, and this is why we have this negative 1 twice. It's what we call a double root. Okay. Alright, so now we need to go ahead and check this, make sure that that negative 1 is going to work when we actually plug it into the equation. Alright, so there it is, plugged in. So the first thing I'm going to do is subtract negative 1 minus 2 times a negative 1, which gives me a 1. And if I take the square root of 1, the square root of 1 is 1. Question is negative 1 equal to 1? Well, of course not. These are not equal to each other, which means that negative 1 is not a solution. And if that's not a solution, obviously this is not going to be a solution either. So in this particular case, there is no solution to this equation here.